So hopefully you have attempted these two problems on your own. Now let me show you how to solve these two problems. For convenience, I'll use only one definition for each problem, and it is your duty to figure out how to use the other definition for each problem. So for the first question, I'll use the first definition. So we are looking for f prime of 3, which equals to the limit of x approaches 3 of f of x minus f of 3 over x minus 3. And you can, and after you expand the numerator of this limit, you get the limit of x approaches 3 of x squared plus 2 minus f of 3, which equals to 11 over x minus 3. And now you can easily see that the numerator of this limit is x squared minus 9, which equals to x minus 3 multiplied by x plus 3. So that's right. The limit of x approaches 3 of x minus 3 times x plus 3 over x minus 3. Let me add the equal sign, okay, and align it. Oh, good. So this limit becomes the limit of x approaches 3 of x plus 3 after you combine the common factor of the numerator and the denominator in the previous limit, and you get 6. Okay, okay, so here we find that the derivative of f of x at x equals to 3 is 6. So let's work on the second problem. Find the tangent sine of g of x, which equals to x cubed plus 4x plus 2 at 2, 18. In order to find the tangent sine, we still need to find the derivative of g at x equals to 2, which is g prime of 2. And now we use the other definition of derivatives. So the limit of h approaches 0 of g of 2 plus h minus g of 2 over h. Here it is, and you expand the numerator of this limit. The limit of h approaches 0 of two plus h cubed plus 4 times 2 plus h plus 2. So this part equals to g of 2 plus h, and g of 2 is just 18. So let's minus 18, and the denominator of this limit is still h. Okay, let me add the equal sign and align it. So we still need to expand the limits expand and simplify the numerator of the limit. So the limit of h approaches 0 of 2 plus h cubed. So by the formula by the formula a plus b cubed, which equals to a cubed plus 3 times a squared b plus 3 times ab squared plus b cubed. So let's write, so 2 plus h cubed equals to 8 plus 3 times 2 squared times h is 12h plus 3 times 2 times h squared, so 6h squared plus h cubed minus 4 times 2 plus 4 times 2 plus h, so plus 8 plus 4h plus 2, okay, minus 18. The denominator is still h. Why do I always forget the equal sign? Okay. So we can combine the like terms in the numerator in the previous limit. So this limit becomes, so we first combine the constant terms. 8 plus h plus 2 equals to 18. 18 minus 18 is 0. So we have no constant term in the next limit in the numerator. So, and we have this limit of h approaches 0 of h cubed plus 6h squared plus 12h plus 4h, so it is 16h over h. Yeah, it is still over h. And you cancel the common factors of the numerator and the denominator. You get the limit of h approaches 0 of h cubed plus 6h plus 16. Wait, okay, so here it is. And the value of this limit is obviously 16, as we can just substitute h equals to 0 into h squared plus 6h plus 16 equals to 16. Okay. So we know that the tangent line of g of x at x equals to 2 is a line with a slope of 16. So if we write this line as y equals to mx plus b and substitute the value and substitute y equals to 18, x equals to 2, and m equals to 16. You get that b equals to negative 14. So the equation of the tangent line is y equals to 16x minus 14. In fact, you can graph the graph g of x and y equals to 16x minus 14 and see if this straight line is tangent to g of x at x equals to 2. I checked this and it indeed appears that the line is tangent. So So the answer is correct. I believe this is pretty much for today, and if you have any questions or suggestions, please tell us as soon as possible. So let's end for today, and thank you for listening. Okay.